Hey guys, I always wondered how could I get more insights from my school community? Maybe you have school community too or planning to do one. The problem is like I don't know which posts are performing good, which comments are good, like getting a lot of upvotes, which members are engaging and which not, or how do I compare to other communities? Like basically information that helps me to find out how can I improve my school community. The problem is, how do I get this data? Because school doesn't offer any downloads or they used to offer. Let me show you. They used to offer an API. As you can see, there's still a URL called schoolapi.com/dashboard, but it has been suspended by its owner. So there's no easy way to get the data. But then I saw a video from Nate about actors and Apify. So if you don't know what that is, that's basically Actor is a crawler that helps you scrape other websites like that are otherwise not easy to scrape, like let's say booking.com or Amazon or even getting YouTube comments, something like that. So I just checked out Apify and I saw, as you can see here, there's a scraper for school community. Not only school community, but for posts with comments and also the media that is attached to those comments. So I tried and gave it a try and run it. And then if you run it, basically you can scrape every community. I think maybe you have to be a member, but yeah, you have to try that out. But if you're a member, it definitely works. So after you run this and you put in some parameters, which we can go over in a moment, you get a big ass JSON file. Okay, so you get a lot of information. Basically, you get everything that is on this site. Problem is, how do I make now sense of all this information? So there's a little bit of work involved. So I dove right into this JSON and tried to create a structure, tried to create a database schema. And yeah, but I basically found a way to make sense of the data, to create some kind of dashboard, and I put it all in N8N so that I can now run it on a daily or on a regular basis to just update all my data. And I save the data in a Supabase database with different tables, which we can take a look in a moment. So you can then use this and like create a dashboard or even send all this information to an agent, for example, and try to get some insights or help use the agent to help you get some insights of all this massive data, because it's a lot. Like it's already a lot for my school community, which isn't that big, which isn't that old. So I can't imagine. I can only imagine how much data you get if you have a community like Nate here in our AAS group. So yeah, let me quickly show you what this is all about. Like, let's give you a quick overview. I'm here back at the old school PowerPoint presentation. So yeah, this is German, but I can translate it. So basically what I did is, from this UJS JSON, I created different tables. First of all, I created a users table. You can see that's not even all the information you get in the JSON, but that's what I thought makes sense. Okay, so the next thing is a posts table. So we have first the user. The user has, of course, all the details like name, his email, his bio, location, but you also get the picture and all their social media handles and when they were joining the group and stuff like that. And same for the posts, you get a lot of data, like has it attachments, what is the content, what is the type, you get the URL of the post and the upvotes. So then I had to try to make a connection, like a relationship between those two, and that's the ID. So you have a user ID, and then we create a user ID in the posts so that we can link those two together. So yeah, users can make posts and posts can have comments, all right? Meaning we have also a lot of details about the comments, like what is their content, to get they get upvoted, when was the latest update of the comment, stuff like that. And of course, we need a relationship. So we have a post can have comments, but also a user can make comments. So we need both those keys as foreign keys in our comments table. As we can see here, FK, that's a foreign key, meaning it references first to the user table, that's the user ID, and second, the post ID that references to the table posts. All right. So in summary, we have 4 different relationships. The user can make posts. That's a one-to-many relationship because the user can make multiple posts. The user can make comments, which is also a one-to-many relationship because the user can write more than one comment. Then posts can have multiple comments. So it's also a one-to-many relationship. And a comment can also have a comment. Because you can answer, you can hit the reply button and so answer to a comment. And so it references itself. That's the most complicated part. So that's it. That's the schema. All right, so let's go to Apify. I did a little wireframe to show you how this works. So we have an actor. We create an actor for Apify, and the actor gets the URL of the community, for example, here. Then we run the actor endpoint, which, let me show you this. Like if you're inside here and you click on API, you click on API endpoints. By the way, you can also watch Nate's video on that. You have here a run actor URL, and later, if you want to get the results, you get this URL to get the results. All right. So we have this actor. And this actor now starts scraping, crawling the website. This can take a while, yeah? Depending which parameters you set. Like if you, for example, only scrape comments from today, posts from today, new users from today, doesn't maybe run that long, but it depends, of course, on the size of your community. But for the initial load, it will take a while. So what you do, or what you need to do, is you need to poll. Start polling. Also, Nate explains this in one of his videos. So you wait and then you ask, hey, what's the status of this actor? Are you finished yet, or are you still working? So if you're still working, you wait again and you run this loop until you get the message, hey, I'm finished, status is succeeded, and then you hit this second endpoint I just showed you, which is get last run dataset items, which gets you this huge ass JSON that I talked about. So what I did now is I created these 3 tables I just showed you in the slides, and I now update or UPSERT all these tables, meaning we check, is the user, is the comment, is the post already in the table, then do nothing. If it's not, then insert or update the user, comment, or post. All right, so that's basically the wireframe for the Apify actor. The thing is, as I said, the JSON is quite complicated. Here, just so you can see it's flat, meaning you can't really tell the relationship between user, author, user, comment, and post. All right, so what we need to do is we need different code nodes. We need one code to extract the users recursively from our JSON file. We also need a code node to extract the posts and map the fields to our data, to our table fields, and we need to do the same for our comments also recursively, and we have to give them a parent ID so you know to which post each comment belongs. And only after we have done this, we can fill now our tables user. In this way, we hit this endpoint, which is my endpoint for my Supabase user table. Then we hit this endpoint for posts, and we hit this endpoint for comments. Okay, of course this can have different names in your database, but I'll just show you that are the names of my 3 tables that are comments, posts, and users. Okay, so that's why I hit those endpoints with my data. All right, so that's it for the setup of all of this. So let's now switch over to N8N and let's try to build that. So I show you step by step how you build that exact structure from this wireframe. All right, let's dive right into it. I already built it out and you can have this template if you want, but of course you need to change the data to your community. But I'll walk you through it. It's faster than to build it now from scratch. So what I did, I started with an on-form submission, but you can also like hard code it, your details here. So I just put in my URL to my Skool community, and then I'll give it a date, like because I already loaded my database. So this was yesterday. Let's just change that so that we get new data. Let's unpin it. Okay, I need my URL. Okay, and let's do yesterday, submit. Okay, so now you have the URL and the data. This is all the parameters you need. Let's pin that. All right, save it real quick. All right, so the next thing is we need a HTTP request to Apify. This is the URL I just showed you. You get it from here. You go to API, you go to endpoints, and you get this run actor URL. Okay. The second thing is you need to send a body, and in the body you need to send JSON, and I'll show you where you get this JSON from. First of all, you go to your community and you need to install something to copy cookies. There's tons of browser extensions. I'm using Copy Cookies, which is a Chrome browser extension. You click on that and then your cookies are now copied, and then you have to go to cookies and you insert them here. Okay, I already insert them, so there's a lot going on here. You just insert that here, you like delete everything else, copy what you just copied, and then you save it. Then you go to JSON and then you copy all of this and just put it in here. Okay, so that's all that stuff. That's our cookies, and down here we have our two parameters. I hand over here the date I just entered, and I hand over here the URL, which is both coming from here from my on-form submission. Here I have the URL and here I have the date. So if you change that name, you have to change that as well. Okay, you can also keep it hard-coded. Okay, so when I start this, the actor will now start crawling the community website. But I don't want to wait. This can really take like 5 minutes, maybe to an hour. Okay, so we do polling. The way we do polling is we get the ID of this run. Every time you start a crawler in Apify, this is called a run. And this run has a unique ID. You get that from data ID. Okay, so I save that in a variable called run ID. Okay. Now I do another HTTP request to get the status of this run, and you can get the status in a way in them you hit the URL, that URL actor runs, and you just add that ID. If you do that, you will get a status back, and the status we can check now. In our if node, the variable is called status data.status, and if this status is succeeded, we can continue. As long as the actor is still running, meaning crawling the website, meaning crawling the community, it will respond with running. Okay. If it will respond with running, this if switch goes to false, and we wait for a couple seconds. For example, 5. You can also up that. Yeah, it depends, as I said, how big your community is, and this will keep polling until the status is succeeded. And when it is succeeded, we go up here in the through branch and we do another HTTP request. And this is to get the results. So this URL comes from, again, we go back to API endpoints and you scroll down here, get last run dataset items. This URL you're now about to hit. Okay. Method is get. You saw that also in the documentation of Apify. When we have that, we get that big ass JSON. So now we do some coding. Don't go into the details of this JavaScript. It's quite complicated and I had a lot of help writing it. As you might have guessed, the most important thing is run once for all items. Okay? Here you run once for all items. Not for one item, for all. This basically extracts the users from this UJS-JSON, okay? Then we have another HTTP request. You might ask, hey, there's a Supabase node. Why don't we use that Supabase node? The answer is simple. The native Supabase node doesn't support UPSERT. That means you can't check in one operation, A, is the user, is the comment, is the post already in the data set? And only if not, insert it. That's what UPSERT means, update or insert. So you can only check, you can only create or get many or delete, stuff like that. So what you need to do if you want to use the native node is I first need to check get all the items and then compare it. Are they already in it? And then maybe do a if switch. Hey, okay, if not, don't do anything. Insert it, and if yes, if it already exists, do nothing. It's way more complicated. So unfortunately, we have to do a HTTP request node, but it's not that complicated. You just have to enter the endpoint, which is the endpoint for my users table. You have to enter the credentials, which is just, I use header out and I just insert my API key from Supabase. And then you have to fill in the content type, which is a JSON, and this prefer resolution equals merge duplicates is basically the UPSERT command. Okay, don't worry about the body. The body is the data we sent, but our JavaScript code already took care of that, so it hands over a JSON object. So we just give it, pass it through. What I also did is I said only do 100 items per batch to not overload the Supabase node. Yeah, so we only do insert, update, UPSERT 100 users at a time, and we do a batch interval of 1 second. All right, same thing for the UPSERT posts, but you see here this means sometimes this can get a little bit confused, meaning it's too much data. Okay, so a small adjustment I made here, I went down to 50 items per batch. It might be you need to go down even more. And in settings, I set a retry on fail. Just in case you got stuck, you have 3 more retries to do. Just wait 5 seconds until you retry. What you can also do, if it is still not working, you can, I guess there's an option. Yeah, there's an option with timeout. You can increase the timeout if you still run into failure, meaning you run this thing, you check Supabase and you see, hey, their data is coming in, and then it gets stuck at some place. So no more data is added. So that's this problem I just described. In that case, just decrease the batch size or up the timeout. All right. Yeah, for the comments, I even went down further. I went down to 20 items per batch because the comments is what you have the most data on. All right, that's probably in the 1,000 or 100,000 in the case of Nate. All right.